Okay, so this is units, whatever unit we're on, 7, day 3, solving. That where you can see it. What was the difference between a solving problem and a factoring problem? The solving problem is going to have an equal sign in it. And so we'll use that equal sign at the end and set the factors equal to 0. So there's the concept for today. Set the factors equal to 0. I feel like we've already done this as well.
But some of these have 2 variables.
Okay, so if there's 2 variables, we won't be able to do it. So we'll be switching back to 1 variable so that you can solve. So you're right, if there's 2 variables, that'd be a little bit trickier. Okay, x to the 4th minus 14x squared plus 45 equals 0. Okay, x to the 4th. Well, a couple things I'm thinking. There's 3 terms, so that usually sets up like this. But x to the 4th means I need x squared and x squared. And then I've got to figure out how to get to 14 with factors of 45. 9 and 5 would work. X squared minus 9 and x squared minus 5. Where they're both negative, so that 14 is negative. And negative times negative is positive. The first one is also a difference of squares, so I can factor that further. X plus 3, x minus 3. I suppose if you're really good, you could maybe factor the next one, but we don't have to, because it would factor with square roots, so let's just leave it as x squared minus 5. And again, if this problem had happened yesterday, there wouldn't be an equal 0, and we would be done. Now there is an equal 0, and we're told to solve, so I need to set each of my factors equal to 0. This is the step that most of you do not write, and that's okay, because you've done it so many times that your brain just knows if x plus 3 is the factor, then what's the solution that goes with that? X equals negative 3. And if x minus 3 is the factor, then x equals 3 is the solution that goes with that. But what about x squared minus 5?
Square root of 5. Plus or minus.
Plus or minus.
So, if you forgot to do the difference of squares, but you ended up simplifying the square root of 9, but you remember the plus or minus,
You'd still be fine. Yep. That's a great question. If you didn't do x plus 3, x minus 3, and you just went from here, maybe even straight to here, because you're like, oh yeah, move the 9 over, square root both sides, plus or minus 3. Yep. Now, my brain's in factoring mode, so, and you guys is too, because you said difference of squares, and so we factored it that way. But you would not have to. You wouldn't have to. X to the 4th plus 8x equals 0. Look how you can see it. X to the 4th plus 8x equals 0. What do you want to do first? Take out an x. And then it's the cube stuff. So, yeah. So same, opposite, always positive for our signs. I went ahead and cube rooted both the pieces. So what goes in the first blank here? X squared. And in the second blank, 2x, because we multiply the two together. And in the last blank, 4. And this still equals 0. Okay, well, this is now 2/3 of an easy problem. By that I mean, if we set x equal to 0, well, that's our answer. Lovely, x equals 0. X equals negative 2. That was pretty easy as well. We've already said that this, when you do a cube, that second piece won't factor. So I can't factor anymore, but I'm still trying to solve it. So if I'm trying to solve a quadratic that won't factor, quadratic formula. Yeah, that's the excitement we're looking for. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Singing always helps. Let's see, 2 plus or minus square root of 4 minus 16. Ooh, negative 12. That means there's an imaginary. What a great problem. We get to use all these things that we've learned. It's so fun. So what does... Definitely an imaginary. What about the square root of 12? Yeah, that'd be 2 root 3. 12 splits into 4 and 3, so 2 root 3, but with an I on it. All over 2. Well, not equals 0, equals x. When this thing equaled 0, we set about solving it by doing the quadratic formula. Still not quite done, because I can divide everybody by 2. So 1 plus or minus I root 3. I don't know that we talked about this, but is there a way to know from the very beginning of this problem how many answers we might have? Well, at the very beginning, it wasn't a cube; it was a fourth. And how many answers do I have?
4.
1, 2, 3, 4. The degree also tells you your number of answers. The degree will tell you the number of answers. And you have to be a little bit careful with that, because sometimes you can have repeated answers. Sometimes you can have imaginary answers. But if you count them all up, there should be 4. That happened on number 1 as well. It was x to the 4th, and we got 4 answers. I think we should go to the worksheet as well. Good call. And 1 through 10, I'm going to skip. You're not going to skip. Is there a back on this page? There is a back on this page.
We should do all the evens.
Yes.
Yeah, some of us have practice tonight.
I'm going to make you a deal in just a minute. Let's look at number 17.
Yeah, Ryan's got a game. I have practice. No time.
No time for this. Number 17. How many answers do we think there's going to be?
6.
6. So already it's like, ooh.
6 answers.
6 answers. How do you want to start factoring this thing?
Wait, is there going to be... Can't we do the one where like move over the 20? Oh, we're on different number than I'm on.
It's a cube root.
27's a cube, but the rest of the problem is not a perfect cube, so I don't think that's going to... But we can do that x cubed and x cubed this time. That would make x to the 6th. And then, oh, this isn't as bad as it looked, maybe.
27 and 1.
27 and 1.
27 and positive.
Minus 27 and positive 1.
Now it's different.
Oh, now we got 2 soap problems.
What?
Right? And 2 quadratic formulas. Yes. So exciting. So start writing smaller, I guess. So x minus 3 right?
Yes.
Cube root the pieces. Same, opposite, always positive. square the first, multiply the two together, square the second. Then x plus 1, same, opposite, always positive, x squared, x and 1. So I'm still seeing 4 answers coming from this. Right? The easy ones are x equals 3 and x equals negative 1. And then, yeah, I've got 2 quadratic formulas. And both of those will give me 2 answers. That's 4, 5, 6. So I will have 6 answers. Guess you're waiting for me to x equals negative b plus or minus the square root 2b squared minus 4ac all over 2a. Yeah, I heard it. 9 minus 36 is negative 27. Factoring cubics, you're always going to end up with an I in there.
If you finish a couple minutes early, the kids have some questions on the dual credit entrance exam.
Okay, I'll be right over. All over 2, negative 3 plus or minus 3I root 3 over 2. And I don't think anything can... I think we should box that. Yeah, there's nothing that will simplify there. It's a bunch of 3's in the top and 2 in the bottom, so as good as that gets. And then we try the other one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 1 plus or minus... I'm trying to do everything in my head, which is dangerous.
Minus 30.
I root 3. Yep, I'm good with that. I root 3 over 2. One last check. Is that 6 answers?
6.
Yep, because those plus or minus, those are 2 each. So 2, 4, 5, 6. Jack says we're done for the day, so we can be done for the day. Now, Jack or somebody said we should do just the evens. And I guess that's fine, because this is today's worksheet and Friday's worksheet. So if you want to divide it up however you want, if that makes you feel better to say evens today and odds tomorrow, that's fine.
I'm thinking
We won't have a new lesson tomorrow because, hold on, some of the classes have a class assembly. Sophomores is 3rd period, so tomorrow during 3rd you'll have an assembly. So that wipes out my 3rd period. So that means we just get like an extra day. Tomorrow I will answer some questions from the evens, probably work some odds, and that'll be it for tomorrow.
I'm scared of number 1. I'm not. Or number 7.
Number 1 looks like grouping.
What about number 7?
Number 7 looks terrible, but I bet it's grouping.
But you can't take out anything. Mr. Why the number 7?
You can take out the squared after that.
Can't you what? Take out squared what?
Squared what? Just take out a square? Don't do that. Don't do that.
You can take out a 4.